Number one, we've set aside, with Bo's permission, a Q&A session at the end of his talk. If you have a question during his presentation, just jot it down in the chat box and we will read that out at the end of the session. And depending on how many we got, we may even open it up for you to ask live and in person. Number two, this presentation is being recorded and we will archive this on a site at the University of Tennessee's Forestry, Wildlife, and Fisheries Department. You can get more information on that by simply asking. And also, you can find this on Facebook. They have a list of all the presentations we've done where you can rewatch it or share it with someone else at a later date. And then lastly, this presentation has been approved by the International Society of Arboriculture for 1 hour Certified Arborist CEU. Now, when you registered, you were given an opportunity, if you were certified arborist, to enter your certification number, and we will take care of it from there. You won't have to do a thing. We'll turn your number in, but we will know if you leave this webinar early. I want to make sure you stay through the entire presentation. So, without further delay, I'm going to introduce our speaker today. Bo Broadbeck. He's an extension specialist in community forestry and arboriculture with the Alabama Cooperative Extension System, Auburn University. He works the whole state of Alabama as an extension specialist in this field. He's based out of Fairhope, so he does a lot of traveling, but he has statewide responsibilities. So Bo, welcome.
Thank you, Neil. It's great to be on here.
Okay, well, good. Super. I do want to add before we turn over to you, Bo, that in some way, this is kind of a reunion for you and me. Bo and I met, I don't know how many years ago. I guess it was like 2005 or 6 when I was with the Alabama Forestry Commission and was detailed to Auburn University to help spend some federal dollars in urban community forestry. And you had just been hired and employed by Extension. And I remember, Bo, that we had gotten a grant for a lot of money to help communities recover their trees following Hurricane Ivan or Katrina, I can't remember which. And as soon as you were hired from day one, that program was handed to you. And I was just amazed how you used those funds and the outreach you did to the communities to help these cities that were devastated by the hurricanes restore their urban forest. I was so impressed with what you did, and it really told me that you had a lot of talent and passion for community forestry, and it explains why you are where you are today.
That was a lot of fun. I've never had more money since administering that. Having a couple $1 million at your disposal to really replant trees in a number of communities across Alabama that have been devastated by Hurricane Ivan and Katrina, and helping them, do some inventory work, remediation. It was fantastic, and it was a good time, Neil. I remember those times fondly. You were a great mentor, and those early years, I was pretty wet behind the ears in the field of arboriculture and urban forestry. I was coming, if you recall, out of consulting forestry.
That's right. That's right. Well, it was a pleasure, and it's just great to have you here today. So let's kind of move in towards your topic. And before we turn you loose, I'd like to have you tell us how you got interested to begin with trees and construction, and then you can begin your presentation.
Yeah, absolutely. It was interesting as I got into the field of arboriculture and started to learn a good bit about different aspects. One of the things that came up was this idea of preserving trees during construction. And my wife is an architect, and she was working really closely at the time with the U.S. Green Building Council with their LEED certification programs. And I used to go with her to a lot of architect functions and some of their LEED certified buildings. And I began to realize that the building construction community just really didn't have a clue on how to preserve trees during construction. And it was really interesting. And I went to some of these LEED certified buildings that were, LEED gold, and all the trees around them were dying, even though they'd gotten this accreditation. And so that really kind of spurred an interest to kind of look deeper in tree preservation, and really begin to communicate it, not just to the arboriculture community, but to the public, and especially to people involved in the building and construction industry, because quite frankly, that is where the rubber meets the road. I mean, amongst arborists, we can talk about it all we want, but there's very little value necessarily amongst ourselves. So that's what really kind of drew me to that. Neil, do you want me to go ahead and jump into the presentation?
Yes.
All right, perfect. So bear with me. Let me share my screen. Don't mind my desktop. Yes, lots of icons. Okay, so thank you all. I really appreciate being invited on here, and I'll go ahead and get started because I'm going to be a little tight for time. I have 3 goals for our talk today. One is just real quick, understand tree function and tree structure, and particularly as it relates to roots. And that's why I called the presentation Getting to the Root of the Problem. In my experience, that's where we have the biggest challenges. I'll then move on and talk a little bit about the impacts of construction on trees, what I've seen over the years, what are some of the big culprits. And then I'll conclude with some of our tree preservation strategies, including a small little study we did here at Auburn University on how to reduce soil compaction when crossing root zones. So I like to point out that trees and people, often collide. It's an issue that we have. When we collide, we end up with diseased trees. This was a tree that used to be in Fairhope, beautiful southern red oak. The houses that were built with these trees in the front, but there was no forethought given to the root systems of these trees. They lasted about 5 years before this whole row of southern red oaks had to be removed, and they were really kind of the focal point of this landscape. Of course, we also end up with dead trees as a result, quite often, of construction damage. These used to be a beautiful live oak down at the Grand Hotel in Point Clear, Alabama, a very famous hotel known for its southern live oaks. And unfortunately, the construction processes have really led to some problems. And of course, we oftentimes end up with tree failures. And I've seen a lot of tree failures, as I've seen a lot of hurricanes roll through the Gulf Coast. And, as an arborist, we can't help it, right? We go out there and evaluate why trees fell. And a lot of times you see root damage leading to a lot of these tree failures, quite oftentimes from the construction of new homes, sidewalks, streets, whatever it might be. And of course, we have the threat to public safety, right? And it's not a lot of people get hurt every year by trees, but certainly there's a number of people that are injured and killed. We just had a father and son killed during some storms here in Alabama about a month ago, with the tree fell through a home, and it's a real shame. And so I like to point out that a significant contributing factor to this and all these issues is the urban environment in which we're placing our trees. And a lot of this stuff is preventable. With better tree placement and design, if we're putting the right tree right place, right? We've heard that 100 times, but it really matters as trees get larger and larger, where we have the wrong ones in the wrong places. Of course, over and over again, we have limited urban tree maintenance and management. Our communities are so pressed for finances. There's so much going on in the communities that trees oftentimes get ignored until they start coming down, and at which point they move up kind of a top priority. And a lot of times we see an overreaction as a result of that. And then, of course, we have damage from development and construction. We have massive urbanization happening in the country. A lot of the studies are showing that our population growth is happening. We're seeing increasingly urbanization. And so our areas that used to be forested are now being subsumed by communities. And how are we going to preserve those forests in such a way that they are going to survive and become a part of our urban forest in the future? And so I think the key, especially when we get out there, and part of this talk, I know some of you guys are going to know this, but part of this is communicating to the public. communicating to the design and building construction teams. And so understanding some of the basics in tree biology and where people tend to get it wrong. And I love to point out that we have to remember where trees come from and their biological needs. Most of the trees, are not native to being planted in parking lots, being planted on the sides of streets to backyards, but instead they come from these communities of trees that we call forests, and they have all these complex interactions in areas, if we remember the sylvics of trees, right, where trees grow best, where they originated from. And so it's important to keep that in mind when we're talking about urban forestry, when we're talking about all the issues that we get. And when we think about those native areas, we have to remember that there's a lot of complex interactions going on that we oftentimes don't see in our urban forests. Just a few, and there's a far bigger list than this. Unrestricted rooting space. When do we see that in the urban forest? Maybe a few parks, but quite often we're planting trees between sidewalks and streets, and we got underground utilities, and we got waterways, and we got the home foundations, all of these issues, and it really limits where roots can go and predisposes them to all kinds of continuous damage. Of course, in our native areas, we have natural soils. When's the last time we saw a good natural soil in our urban environments? Most oftentimes we scrape it away, right, and bring in some type of red clay that's great for engineers, but terrible for planting trees. Of course, we're lacking organic matter. A lot of times we don't have natural drainage. We change the drainage around trees. And what I find kind of as an interest is that we have in the native areas, shelter and shade from surrounding trees. We don't have that. A lot of times we have specimens all by themselves. That becomes an issue when we start talking about straight line winds. And then underlying all of this is a slowly evolving ecosystem. And that is something when you think of a tree that maybe used to be in the forest and now we started to clear around it, to put in a subdevelopment around it, and a tree that's maybe been there for 50, 60 years, it has become accustomed and adapted to a site. In a matter of 3 months, we can completely change the environment of that tree. The drainage can change. The amount of root system it has, it changes. The soil properties can change, and the list can go on. And then we wonder why we have so many issues. And so I like to point out that instead of a forest, we have plugged forest trees into a much harsher environment. And when you talk to the public, they're always surprised when they buy their new house that had trees in the front yard. And 1 to 2 years later, they're calling you going, why are all my trees dying? And it's great to have pictures like this to say, well, let me back you up and probably show you what happened to your trees. We lost roots and we lost all of these types of damage. And so I like to point out as well that most mortality in urban trees, in my opinion, begins with a lot of abiotic factors, right? Especially during the building construction phase. We have things like root removal, soil compaction. We change the grades and bury the root system of trees. We change the drainage around those trees. It either is now wetter than it ever was before, maybe drier than it ever had been. And of course, we sometimes can change the soil chemistry and change the pH of that soil. And I know you all have probably seen the Mannion decline spiral, kind of that great model that shows us how we go from healthy trees to stressed trees to declining and eventually to dead trees. And it's this idea that we begin with predisposing factors. And at the top of that list, we have the, hold on, let me see if I can get my pointer to work here. And at the top of the list, we have the urban environment, right? All the stuff we've been talking about. We might have genetic potential of the trees, maybe not well adapted to a site. Of course, our urban soils are oftentimes compacted, and all of these things predispose trees to move from healthy, down towards stress. Of course, and then we get our inciting factors, right? We can have some native pest outbreaks, things that happen every year, fall tent caterpillars or eastern tent caterpillars. Any of these kinds of things that start to defoliate our plants. We might have some excavation and some root damage. Maybe we have some drought. Maybe it's been 6-8 weeks since we've had any rain. And all of these things take us and push the tree from healthy further down into stress and maybe towards declining. And then we get the contributing factors. And this is, in my experience, where most of the public warning bells start to go off in their mind that they have a problem with the tree. When they see, canker fungi all up and down the side of the tree, or they see wood-boring insects. They see frass all around the base of the tree, or they see pitch tubes in their pine trees. And that's usually kind of that last straw that pushes trees from declining down towards dead. But a lot of times, if you kind of, unwind this spiral, you end up with a lot of abiotic factors that took those trees from being kind of vigorously growing and pushed them further down towards stress. And so many of these problems during construction, they begin in the roots. People just don't understand what roots look like, how they grow. And I love this picture of this gentleman, very proud of his sidewalk, that, it's kind of snaking through these trees. It's kept these trees, not realizing that we probably have some pretty significant root damage that, might affect the trees biologically, and maybe they won't be around for very long, but certainly might affect them structurally, and safety might be a concern as well. I love this quote by Dr. Alex Shigo that says, if someday we are to know everything there is to know about the above ground portion of the tree, we will still only know half the story. And in my experience in talking with folks, it's that half the story below ground that gets us into trouble time and time again. And if you get out there and you start talking to the public, you talk to maybe architects, my wife's now very well educated in this, but you start talking to maybe engineers and developers, and you start talking about tree roots, you realize that a lot of the information out there is based on hearsay and convenience. You have ideas, roots only go as far as the drip line. Trees have these big, massive tap roots that might go down and, reach some underground aquifer. That's where they're getting their moisture. Roots or deeps, oftentimes kind of a mirror image of the above ground portion of the tree. And what's interesting is if you start looking at textbooks and diagrams, not from scientific sources, just drawings, they really kind of reinforce these ideas. So it's no surprise why people kind of end up with these notions. And of course, I really kind of like this drawing done by the Morton Arboretum many, many years ago of a field-grown white oak that really gives us a clear and more realistic perspective of what roots look like. I mean, taking the caveat that there's a lot of issues that might have the root systems be a little bit deeper, and it's usually based on soil types and so on and so forth. But kind of the takeaway message is that roots are shallow. We know that 80 to 90% of a root system is going to be in the top 18 inches of the soil profile. They're widespread, oftentimes going 2 to 3 times the drip time. I often tell people if we lay a tree down, it'll give us a much clearer idea of how far those roots extend. And of course, we have to remember the function of those roots. Just, very basically, they are to absorb water with those dissolved minerals that are pulled up into the tree, are used in the photosynthetic process so that we can put on, wood, we can put on new roots, we can put on new shoots and leaves and have growth. But they also serve a function for structural support. And this is usually the one that I find really gets the public's attention when I start telling people, well, if you start cutting away the root system, you affect the tree maybe biologically, but as you start getting into this area that we term the structural root plate, or that area of rapid root taper, you now affect the ability of the tree to stand. And I love the analogy that Jim Urban uses in his book Up by Roots, which is the idea if you put a wine glass on a dinner plate, where the dinner plate is kind of the further extent of the roots, and you cut some of the away part of the dinner plate, you're cutting away the biological capacity of the tree to absorb water. But you start cutting into that root plate at the base of the wine glass, you affect the ability of the tree to stand. And where I am down here on the Gulf Coast, hurricanes are a way of life. It's not a matter of if, but it's a matter of when the next storm. But in other parts of the country, we get straight line winds, we get thunderstorms, we're brushed by tornadoes, and all of these things can really affect how trees stand if we get too close to the root system. And there's just a kind of some ideas of how big the root system is based on the DBH of the tree, the structural root plate. So let's move on and talk a little bit about the impacts of construction damage on trees. How do we get ourselves in trouble? The first one, of course, is one of the most obvious. It's mechanical damage, right? So it's that idea that we have a physical injury to the tree. The bonehead driving the skid steer dings the side of the tree. He's not paying attention to where he's going or doesn't care, and skins the side of the tree, knocks off some of that bark. And we know that the bark is kind of keeping the outside world from getting into that tree. And when we open it up, we're introducing the possibility for fungi that'll turn into decay pathogens. We potentially open the tree up to infestation by insects. We know that if, that smell of turpentine is attractant to pine beetles. And if we have enough of it knocked off all the way around the tree, of course, we're going to girdle the tree, right? And this over time can lead to the formation of weak structure. And we have to remember and tell people that, trees don't heal, they seal. We have this thing of compartmentalization of decay, how we wall off decay in trees, and that there's some species are better at it than others. And so when we damage trees physically, we are setting them up to have hollows and rotten spots inside those trees that'll come back to haunt us, maybe not biologically, but certainly structurally in the years ahead. And Neil, since we were talking earlier, I'm sure you know who this guy is. This was taken after Hurricane Katrina down in Mobile, Alabama. As a tree that had some structural damage. It's completely hollow now. So water oaks are terrible at compartmentalizing decay. And of course, we now had a tree that failed. And really the winds were not that strong in Mobile from Hurricane Katrina. They were only like 70, 80 miles an hour at most, nothing like we saw over in Mississippi and Louisiana. So the second big thing that we run into, of course, and it's kind of the second most obvious one, is root removal. And people say, well, how much roots can you remove from a tree? If you start looking at the literature, there's not a lot of good literature on this. But kind of reading between the lines, survival becomes questionable once we start getting over about 40% of a tree's root system being removed. And so, however, if trenching or something occurs, within the root plate, safety becomes a concern. And this picture is in Mobile again with the new urban forester that was hired a couple years ago. Street department came in, was fixing some buckled sidewalks, and this was their solution, to just grind away all the structural root plate on this tree. This was one of the largest live oaks in Mobile. And it's a tree now that's really set up for failure in the years ahead. Because we have to remember that we not only lose the immediate strength of that wood, but when we open it up, just like we do with the above ground tree with physical damage, we create a pathway for decay as it moves kind of in those structural root plates back up towards the stump of the tree. And so we not only lose that immediate strength, but we're going to lose strength in the years ahead. And I found this article a few years ago, and I was kind of looking up for a presentation where, and I only have one picture, but there was multiple pictures of the trees all along a sidewalk where they put in a new sidewalk. They chopped all the roots. I have the arrows here really kind of highlighting those cuts, and a whole row of trees had fallen over, mostly on cars, as a result of some straight line winds. And so of course, homeowners realized that, the new sidewalk and all these cut roots was a contributing factor. So the other way that we get ourselves in trouble, it's a little more subtle. It's one that it doesn't have usually immediate impacts, is changes in grade and burying that root system on trees. And we know that roots want to be up towards the soil surface, particularly our feeder roots, because that's where the trees have access to moisture. That's where they have access to that organic content. And this was a cool picture taken by Ed Gilman at the University of Florida, where he purposefully planted some trees too deep. And look what he found. They grew right back up towards the soil surface, where that water, where those nutrients once, and he actually found that the trees were less stable when they were placed in the ground too deep. What we have a tendency to see sometimes is for around larger mature trees, and when we have big changes in the grade, a lot of times, especially with older trees, that original root system tends to die back, maybe rot away. If the tree is young enough and vigorous enough, it might grow a secondary kind of advantageous root system up towards the soil surface. But if the trees are older, a lot of times they don't have the energy to do this, the energy reserves to do this. And so you end up with a rotten root system and a potential for failure. And so these are some trees, unfortunately, taken at Auburn University, where they had them all in these wells, and we're beginning to see them fail. There was one that failed late last year and kind of struck one of the walkways going into the Auburn University library. So the question oftentimes comes up, well, how much fill can I add around my tree, right? I'm sure if you've dealt with anybody, that question has come up. And this is a great little diagram done by Kim Coder at the University of Georgia. And, he basically says, it really depends on the type of soil, because we're thinking about how much air and water movement based on different types of soil. And so he suggested that if it's a pure sand, which is going to have a lot of air and water movement, you could get away with as much of 8 inches of fill all the way around those trees. And of course, as you start adding a silt and clay content, the amount goes down. And if you end up with a pure clay, which we know, when you pour water on, it's just going to run off, not much air is going to move in, as little as 1 inch could, over the entire root system of the tree, could be detrimental. It could be the same as paving almost around those trees. And so it's something to be avoided. Now, this damage to construction, soil compaction, tends to be what I like to call kind of the silent killer of trees. It's very subtle. It happens over a period of time. It happens in combination with all of the previously discussed issues. We know that an ideal soil should have, that 45% pore space, that space for water and air to be in the soil, to have that infiltration of air and water. But unfortunately, we oftentimes don't have that. Sometimes our urban soils are already compacted to some degree, and then the construction process can really lead to a lot of compaction. Whether it's the actual equipment that's running back and forth, or it's the equipment getting into the site back and forth across the tree system, or where does all the construction workers want to park, right? They're going to park in the shade up underneath all of those trees. And if you do this day after day, week after week, we end up with a substantial area around those trees compacted. And as you compact those soils, the first thing you're going to do is you're going to crush a lot of those feeder roots that are right up there near the soil surface. So a lot of those are going to die back. Of course, the tree, if it's vigorous, is going to kind of grow some back. But over time, you're going to reduce how much water and how much air is getting into the soil. So you're going to see increasingly more runoff. And then you're going to see some, and before I get to that, one of the questions that also comes up is, how quickly can I compact my soil? There's a great document published by Kim Coder in 2014 at Georgia that said, as little as 3 passes on the right soil can compact a soil down to 95%. So we know that soils that are higher in clay content, and certainly wet soils, are going to be far more compactable. Down here on the Gulf Coast, we have a little bit of leeway because we have more sand content. And so think about that when you're thinking about compaction. If you have more clay, and if you're running equipment on wet days, you're going to have a lot more compaction, but it can happen pretty quickly. A paper published by Neely and Watson back in the 90s suggested that, if you compact the soil down from that, 45% pore space down to 12%, you pretty much stop all root growth. The roots cannot physically punch through that soil any longer. And of course, different pieces of equipment have different weights, and they're going to apply different pounds per square inch. A cement truck's going to be putting down something like 110 PSI. Some of your, bucket truck or something like that might be 40 PSI, a pickup truck's 25, and just even people, enough foot traffic over a certain area can slowly begin to compact that soil over a period of time. I mean, just think about it. You see that a lot of times when people take that shortcut across the grass, and you see those compacted little trails, and nothing grows there now. Well, we've crushed it. That's not been heavy equipment. That's just people walking back and forth. And so the question comes up is, what happens to trees under compacted soil conditions? And there's a number of things, but one of the ones I wanted to highlight is, first of all, soils become anaerobic because you don't have any of that air movement. And so, we continue to have, decomposition and respiration going on. And this process releases carbon dioxide. And when it releases it underneath the soil and you don't have any air movement in and out of the soil, it gets locked into the soil. And you create these pockets of CO2, like we're seeing over here. And it puts a lot of pressure on some of our microorganisms, like mycorrhizae and things that help with the tree growth process. And maybe we end up with some less advantageous microorganisms in the soil. And so you end up with these areas where roots are not able to grow as CO2 builds up in those soils. And of course, Soil compaction is often evident, when we look at it by things like, chlorosis in our leaves. We might see patchy growth, dieback in our canopies. If you look at the ground, you see kind of these patchy areas where, not even grass will grow. And we end up with, when we look at trees, we tend to see short, stubby roots. We saw this with our famous tumor oaks that were famously poisoned with a herbicide. And when they were trying to preserve those trees, they pulled up the system, and that was a highly compacted site. And if you ever saw pictures of that, there was these short, stubby roots because the roots really were having a hard time punching through that thick soil. We oftentimes end up with shallow roots, which of course gives us less physical space for the roots, right? We see more damage to infrastructure of the rate. We see more conflicts with mowers because those roots are right up near the soil surface. And then of course, those roots and those trees now are more subject to drought because the soil that's going to dry out the fastest is the top few inches. And if all of your roots are right up only in those top few inches, the tree does not have the capacity to survive a prolonged drought, and as well as things like temperature changes. And so you end up with kind of these unhealthy trees with extensive bred branches over a period of time. And it tends to be a silent killer because it's not immediate in most cases. It can take years, if not a decade, for these trees to slowly decline as a result of some soil compaction. Of course, lessons we've learned with storms is that the shallower the root systems, the less wind resilient they are, right? Down here on Alabama's Gulf Coast, very, very important. But we get storms all over the country. And so we know that those shallow rooted systems are much more likely to go over, especially when we have prolonged rain events and the trees are not able to hold on to that soil as well. And then the last damage I would like to mention is changes in soil chemistry, right? It's the big one we see is things like concrete washout. This picture I took here on the left, a homeowner had asked me to come look at this tree because it was leaning. And while I was there, she was doing some renovation to her house, and the guy was literally washing out concrete and drywall and all kinds of stuff all over the base of the tree. And I tried to explain to her and the subcontractor that this is not ideal. You're changing your soil pH because we know that concrete has a pH of around 12, and the ideal range for trees is going to be 6.5 to 7. We know that some species like it more basic or more acidic, but roughly we don't need it around 12. And so it is an issue as we stockpile materials and all this stuff over time, we can begin to change that soil chemistry. And a lot of times if you take a soil sample after the construction, you see some pretty funky soil pHs around construction sites. So that gives us, I've talked about, a little bit of structure, understanding how we get ourselves in trouble. Now let's talk a little bit about tree preservation strategies. There's a planning sequence. This is not, you don't have to follow this exactly, but it is a good guide. We start with a planning phase, and we'll talk about each one of these in a little more detail, is the place where we're determining the trees that are worthy of preservation. Just because it's there doesn't mean we need to be preserving it. Then we move into the design phase where we kind of work with the construction and design team to review the design in relation to the trees that we're hoping to keep. And then we move into the pre-construction phase where we review the construction plans to develop a tree protection strategy of how we're going to keep these trees. And then we kind of move into the construction phase, which is really just site monitoring. Make sure that the plan you put in place is being adhered to. And then post-construction, where we're kind of prescribing some stress reduction measures. Good tree protection and design happens during site planning and prior to construction. I can't stress this enough that quite often it's very unfortunate that a lot of us get called way too late in the process. The building's been designed, half the roots have been dug up, they've been parking under the trees for weeks, and then the warning bells went off at some point for somebody, and then they decide to call you. In many cases, it's too late. You're dealing with mitigation rather than preservation. And so getting a team together, whether we're talking about one lot and you're doing infill development, or we're talking about a whole new subdevelopment going in, getting the planners, the architects, the builder, the developer, the engineer that's going to be working on the project, the landscape architect, whoever the city management is, the urban forester, everybody on the same page, because quite frankly, tree preservation is very simple. And it doesn't really even have to cost a lot of money, but people have to understand how it works and why you're doing certain things. And so getting all these people talking and communicating will ensure that you have a good tree preservation. So as I mentioned, the first phase is the planning phase. Really, if you're looking at a big subdevelopment or a small one, you're going to be inventorying and doing a condition assessment, determining which trees are worthy of consideration. You want to be asking yourself, what's the chance this tree is going to be around in 10 years? You don't want to preserve some over-mature tree that's really on its way out. By the way, this is when we want to hire an arborist. This is when the arborist should be coming in. They should be doing this inventory and condition assessment. It shouldn't be done really by the homeowner or the engineer or whoever thinks they have knowledge about trees. Because there's a lot to consider when we're thinking about, which trees are worthy and which ones to keep. One is, over mature trees are difficult to preserve. If the tree is already mature, it's going to be more sensitive to construction damage, because it's almost impossible to preserve a tree and not have it lose some part of its root system. Some species are also more sensitive to root damage. A good arborist is going to know which species are more sensitive and which ones can handle it. That might factor into which trees we are able to preserve. Some species are more susceptible to decay and diseases. We know that if we have to cut some roots away on a laurel oak or a water oak or a hackberry, that we're going to end up with problems as opposed to some other species that are better compartmentalizers of decay. And then, of course, small and medium-sized trees have much smaller critical root zones, are much easier to preserve than some massive tree on the property, which is probably the one that people are focused on. And is it realistic that we can actually keep this tree alive, considering what's going to be built there? And you should always be doing not only a health assessment, but also a risk assessment. We don't want to be preserving trees that have cracks, that are maybe leaners, that are just going to create safety issues years down the road. And then we move into the design phase. So once we've kind of done the inventory, we know what's out there, which trees we probably are good candidates to preserve, then working with that design team to say, okay, what are we building here? Where is it going to go? Where's the driveway going to go? What fill is going to be done? Where are our underground utilities going to go? And have that design place, and then place those trees you did on the inventories as a layer, especially for a big project, in that, whether you're using GIS or whatever software you're using. And what you don't want is what you're seeing in this picture, where we have, this big building going in. It's an Alzheimer's facility, big building. We see kind of where, the impact lines are going, and we have these trees. And if y'all can see this, it says here, white oak. This one over here is a post oak that's 43.5 inches in diameter. Massive trees, but we have no idea what it takes to preserve these trees. We just know they're there. And a lot of times, that's good enough for a lot of the design and building construction people. Yeah, we know it's there and we're leaving it. And unfortunately, that's not going to get us successful tree preservation. Instead, we need to understand what the tree's critical root zone is, right? This is the area that is essential that the tree keep those roots if we expect the tree to survive. Because all tree preservation is preserving an area of soil under that tree of a certain size that is relatively undisturbed. And so we know that the formula for CRZ is DBH, diameter at breast height, multiplied against a multiplier, most often in feet. And so if we have a tree that is 21 inches in diameter at DBH, a generic multiplier might be 1 foot. And so it gives us a radius of 21 feet that is critical that this tree keep if we have any type of expectation that it's going to survive the construction process. Of course, one of the tricks to this is trying to understand that multiplier, right? And this is where the more experience you have as an arborist or an urban forester is really critical, because that multiplier is based on a number of things like the tree's construction tolerance, is it a good compartmentalizer, the relative age, what's the overall health of the tree? And that's where that early inventory you did is really critical. So we know those species, and we can start figuring out, because we know that the range that at least ISA outlines in their BMP goes from a multiplier of 0.5 to as high as 1.5. And I've seen people prescribe even higher, maybe 2.0 for maybe a large over-mature tree that is very sensitive to construction. And then based on that, and so you have to adjust that. You just can't throw a number out there. And there's a lot of books that'll help you highlight, which trees. Nelda Matheny has the book Trees in Development that has some good lists. And there's various public extension publications around the country. I would try to find one that is more locally sourced to your area because, so that the knowledge is closer to where you are. And so then once we know that critical root zone, it's imperative that we put it in the drawings so that we can see, okay, how much of this critical root system are we going to lose? Can we move the building at all? Can we move the driveways over to one side? Can we move where the underground trenching is going to go? And so you can start looking at how we're going to design around these trees. And if it can't, then you have to make the decisions to potentially remove some of those trees. And I like to tell people I would much rather have these trees removed in these early phases when somebody can do it with a bulldozer or something and it doesn't cost you thousands of dollars to have an arborist come out there and climb the tree and take it out piece by piece by piece. Let's go ahead and do it early, or have the tree die 2 to 3 years later, which can be a real heartbreak, particularly for homeowners and subdivisions that may have bought that tree with the expectation, or bought that home with the expectation that that tree would be a part of their landscape. And so we want to plan our travel corridors as well, right? And so it's imperative that we don't let this happen. Let the builder and all the subcontractors figure out where they want to stockpile things, where they want to drive, where they want to park. Instead, we really want to plan those travel corridors. Give people, this is where you're going to stockpile materials. This is how you're going to access the site. This is where the workers have space to grow, and the rest of it, we're gonna put fencing around it. And so we identify the CRZ, and then we're gonna identify the TPZ, which is that it's the tree protection zone, or it's the area that an arborist defines outside the critical root zone. So it's an area that usually encompasses multiple trees on a project. And I'm starting to pick up the pace here because I'm realizing I'm running out of time. And then we put in our exclusion fencing. In my experience, the bigger and meaner the fence, the better. It's good to have signage so that everybody in the project knows why that fence is there, and particularly maybe the subcontractors who weren't at those early meetings. And then it's also important, because we are going to have to remove some roots, that we remove the roots outside those CRZs or those TPZs in a way that we don't damage them more than we have to. In a perfect world, we're going to Airspade it using, air to air excavate a trench, and we're going to do it by hand. In a less perfect world, we might use a piece of equipment like one of the saws used to cut, asphalt or cement, and just go down and cut through those roots. What we don't want is the backhoe guy to come in and rip up these roots, so we have root damage extending way inside our critical root zone. And then we might consider using some compaction reducing techniques where traffic is expected inside our TPZ or CRZ. Quite oftentimes we measure those. Maybe the trees are at the front of the property, your house is at the back, and we're going to have to get all the equipment across the root system of that tree. And so we need to have something to try to reduce that compaction so that we're not, smothering those roots over time. We did a study on this topic. Oh gosh, it's been about 7-8 years ago at Auburn University, because as we started looking at a lot of the BMPs that are out there, there wasn't a lot of research and on why we're prescribing certain things. It was based on a lot of anecdotal evidence. And so looking at a lot of the prescriptions that are out there, we designed a study where we were going to evaluate how good they were at reducing compaction. We were looking at 8 inches of mulch, 8 inches of mulch with 3/4 inch plywood on top of it, then using a geotextile with 8 inches of mulch on top of it, and then of course our control with nothing. And then we, laid out these small plots. This was a very small project done on a shoestring budget, and so we had these kind of small plots with the different prescriptions on there. And then we grabbed a big old heavy truck that weighed about 17,000 pounds and ran it over these multiple times. We had some of our replications that we ran across them just once. We had some that ran over it 5 times, and then some up to 10, trying to simulate, multiple times going over the certain areas. The data we were collecting, we looked at both soil bulk density, sampling at 2 depths, 0 to 8 inches and 8 to 16 inches. And then we also used the subsurface soil pressure, and that's kind of this little bulb. So we buried this bulb about 8 inches under the ground, and it basically measured both the initial pressure in the soil, and then the residual pressure. So how much the soil, uncompacted after the truck rolled off of it. And so real quick, our results found that, of course, as you would expect, our control with no measure on top of it, did not obviously had the most compaction. Interestingly, just 8 inches of mulch wasn't a whole lot better than the control. And then we were pretty similar with both our mulch with plywood and our mulch with geotextile from looking at the bulk density data. I will add that the site we were using already had some soil compaction on it. It's hard to find a site that somebody will let you compact that was, perfect. So we had a little bit of variability. That's why if you look at these figures, we were already, fairly compacted to start with. And so we looked at our pressure bulb data, which was a little more interesting. And what you're looking at here is that the blue bar is kind of the peak pressure. So when that tire was directly over the bulb with whatever that prescription. And so for our control had no, we could see that the peak pressure continued to increase, and then the residual pressure increased a little bit slowly. Now, while I'll note here is that a lot of our bulbs burst after about 4 to 5 passes. And so it kind of plateaued here. So I would expect that if they hadn't burst, that it would probably have continued going up, but we don't know that for certain. And then if we looked at our other measures we were using, of course, the mulch plus plywood, it was registering virtually nothing on that pressure bulb 8 inches under the soil. Just the mulch was registering just a little bit. And the mulch with geotextile was, measuring, maybe 1 pound per square inch up underneath the soil. So it also worked pretty good. So, the takeaway from here is these construction reduction measures work pretty good. And so kind of the conclusions of our study, and also looking at the literature, and particularly another study done by Lichtner and Lindsay in the 90s, that most soil compaction occurred near the soil surface. We didn't see anything at any of the deeper depths. And the tested prevention practices do provide some relief from soil compaction. It does not prevent it. It still occurs. It just reduces it to some degree. We don't know the long-term effects. We only did 10 passes. I think Lichtner and Lindsay did something similar. So we don't know what it's like if you run that piece of equipment 50 or 100 times over the life of a construction process under trees. And so based on this, we kind of come up with 3 techniques that you might consider depending on the scenario to reduce compaction around trees. I put this one in using something like plywood or alternative mat just on the ground because it comes up quite often. And this is really only viable. We found both in looking at the literature that these do not prevent compaction. All they prevent is rutting, but the compaction is still occurring. So it's really only good for, doing tree maintenance, right? Getting in on the yard to, prune the trees, do tree care, but it's not a viable method for preventing construction during a construction process. The next one, if you're going to have, lightweight traffic, infrequent traffic, maybe, light equipment like a pickup truck. If you're going to have a lot of foot traffic, the construction crews working in, around, and underneath the trees, it's advisable to put down 8 to 12 inches of mulch, just to help reduce that compaction, because enough foot traffic, especially on wet soils and clay soils over time, can create some surface crusting. And then, of course, it's imperative that we remove that mulch down to 3 inches at the end of the project. If you're expecting heavy traffic, so those where you're going to have equipment running over, getting all the equipment over that root system of the tree, if you can't get it around the trees, using 8 to 10 inches of mulch, putting a plywood on top of it or a steel plate, whatever it might be. And we really recommend the geotextile underneath. Even though our data didn't suggest it really helped reduce soil compaction, what we do realize that it does is it does 2 things. One, it'll likely keep your wood chips from grinding into the soil profile. So you're going to keep that layer of chips a lot longer. And at the end of the project, when it's time to remove the excess mulch, you can tie that geotextile to a piece of equipment, back it off, and pull that mulch all off. And so you're not having to get in there with some type of a skid steer and risk doing root damage, digging it out. This is what it kind of looks like, coming in and you're putting some type of heavy geotextile, putting your mulch on top to create that roadway where you're going to get the equipment across the root systems on those trees. So as I move towards our conclusion, we then get into our construction phase, and that is really site monitoring. So we're going to be policing that tree protection zone. We're staying in contact with the construction team. We're monitoring tree health. And what's real important here is evaluating and monitoring the landscape installation. I can't tell you how many projects I've seen where they've done a pretty good job on the tree preservation, but then the landscape guy comes in and he regrades the site so that the grass is perfectly smooth. He trenches through there, installing underground irrigation, and then he digs a bunch of holes wherever he wants, regardless of where roots are, to plant plants. And we end up with more damage. We have to remember, a lot of these trees, if you remember your Mannion decline spiral, it's layer upon layer of issues. And so it's soil compaction, it's some root removal, it's, additional root removal during these processes. And so we want to try to minimize that as much as possible. And then we move into the post-construction phase. We're not done yet. At this point, you're really trying to baby those trees. You're realizing that you've probably lost a lot of root system. You probably have a little bit of soil compaction. So kind of babying them along. How to do this? We know that mulch is the silver bullet, applying 2 to 3 inches of mulch over your CRZ. If you can avoid having grass under those trees, great. And then monitoring the trees for pests, monitoring them for things like ambrosia beetles, pine beetles. If you suspect that they might, maybe doing some preventative treatments with those trees. And then of course, consider irrigation. Assuming there's not a water threat in your area, you might consider irrigating them if you feel that you've really kind of pushed the limits of their critical root zone. So with that, I will bring my talk to a conclusion. I apologize, I didn't leave a lot of time. But I love these 2 quotes, particularly the second one from a colleague, Jack, that I work with closely here in Alabama, that, it's important to not make trees a barrier, but make them part of the plan. Tree preservation is very simple if people just understand how it works. What's complicated is mitigation. When we start getting into things like vertimulching or airspading and trying to get rid of compaction, those are complicated and usually don't have very good payoffs. So with that, Neil, I will stop talking and see if we have any questions.
Okay, thank you, Bo. Very detailed and very comprehensive. Great information. Christy, how much time do we have left for Q&A?
We have about 3 minutes.
Okay. Do you have any questions in the chat box?
We don't have any questions right now. We may want to give people just a second to pop those in.
Okay.
The chat box.
While we're doing that, I have one quick one, Bo. Obviously, you mentioned get involved with the construction team in the planning phase, a lot of different players in construction. There seems to be a lot of mistrust between the tree protectors and construction folks. In a lot of cases, we've created this problem ourselves. How would you recommend we approach the construction phase of development in a more positive way so we can be more engaged? Does that make sense?
It does. And Neil, unfortunately, one of the issues we run into in our borer culture is I think a lot of times we're seen as kind of these blue collar tree cutters. What do they know? And unfortunately, sometimes we don't help ourselves, with not presenting kind of a professional front. And so I think for our arborists that are working in this, trying to maybe visit some of these firms, architecture firms, building construction firms, working with the the homeowners association and presenting at their firms. Do a lunch and learn. Architects have to do lunch and learns. Go present at some of these groups, educate them, and be there as an educator and not kind of looking down your nose at them, but also kind of preventing that professionalism that we are bringing, research and information to this, and building trust with these groups. Does that answer your question?
Yeah. It's building relationships, mutually beneficial relationships. Good point. Christy?
Yes, we do have a question. So Bo, if there's a single tree left somewhere, does that make it more susceptible to lightning strikes? And what would we do about that?
Ooh, I don't think so. I don't think it makes it more or less susceptible to a lightning strike. I don't have a real good answer for that. I mean, if it's the only tree on a hilltop, you know, it might be more susceptible, but if you had a forest up there, it would also be susceptible. It's just you have more choices, right? So if you have one tree out there and you're worried about lightning strikes, you know, we do have lightning protection that can be installed. It's very expensive. But if it's a high value tree that you're worried about, there's arborists out there that can install kind of the copper cables going all up. There's methodologies for that. And it can really, it's not going to prevent lightning strikes. It's just going to guide that lightning from the top of that tree and dissipate that energy away from the tree so it doesn't damage the tree or damages it less.
Okay, and so far we don't have any other questions, just compliments on your presentation. So everyone seems very happy with it.
Either that or I put them all to sleep, one of the two, right? So.
Nope, everyone, you even got a comment that says mesmerizing, so good job.
Thank you. Whoever made that comment, thanks.
All right. Well, Christy, it looks like we're at the noon hour here, and we'll just wrap it up. Bo, thank you so much. This has been time well spent. I always feel like if I've sat through a presentation and come away a little more knowledgeable and inspired, then it was worth it, and you accomplished that. And based on the comments, there's a lot of agreement there. So thank you.
You're very welcome. And it's, like I said, great to be on y'all's series. And if I can ever be of service, my email is down there at the bottom. Folks can send me a note and I will do my best to respond to you. So thanks, Neil. Thanks, Christy. It's a pleasure to be on here today.
Thank you. Great.
Thanks, everyone.
Okay, Christy, do we have any information on next month's webinar?
Yes. So next month, I can get my screen up. Next month, we'll be joining Alana Tucker from Tree City USA and Tree Campus USA on September 16th. That link or that webinar is already, you can go ahead and register for it. If you have not done so already, the link is tiny.utk.edu/urban-forestry.
Okay, great. And these two presenters are with the Arbor Day Foundation. One's in charge of the Tree City USA program, and the other with the Tree Campus K through 12 program. And we're hoping that a lot of educational institutions and municipalities that are not participating in those Arbor Day programs, that we can reach out to them and where they can learn more about them and hopefully get involved. So if y'all can help us spread the word on that, we'd appreciate it. But we'll end it with that. And thank you again, Bo, and stay safe down in South Alabama. And we'll see everybody next time.
Thank you.
Have a good one.